Let's learn set theory.
set theory.
Let's start with similar sets, also known as equivalent or equipotential sets. Two sets A and B are similar if and only if there exists a bijective function between them, and then we write A is similar to B. Note to students, two finite sets are similar if their cardinality are equal, and the relation of similarity of sets is an equivalence relation. Make sure you know that an equivalence relation is a concept which is used to describe a relationship between elements of a set that groups them into equivalence classes based on a certain criteria. Also note that the main difference between a finite and an infinite set is that every infinite set is equivalent to at least one of its proper subset. In the previous video, you learned about counting over functions. In this one, we'll see about counting of a set. As defined, a set can be put under the counting system or process if a rule can be imposed over the set by which the successor is defined. And a set is defined as either countable or uncountable based on countability. Before defining those two, let's first know about countably infinite sets, which are when a set S is said to be countably infinite if it is similar to the set of natural numbers. Now, let's learn about the countable and uncountable sets. So, a set S is countable if it is either finite or countably infinite. And a set which is not countable is uncountable set. Have this knowledge about cardinality of infinite set of natural numbers and real numbers, where order of n, that is natural numbers, is LF0 and that of real numbers is continuum. Moving on into the arithmetic of cardinal numbers, but before that, let's define transfinite number. A number is said to be transfinite if it is larger than any finite number, but not necessarily absolutely infinite. Thus, for any transfinite number, alpha, beta, and gamma, alpha plus beta equals larger of alpha and beta. Alpha beta equals to larger of alpha and beta. It's basically as if, since we can define a certain value for these transfinite numbers, we just tend to move towards the larger number. Some properties on cardinality of sets. Now, let's see algebraic numbers and transcendental numbers. So, a real number is called an algebraic number if it is a root of a polynomial p of x equals a0 plus a1x plus ... plus an x raised to n equals 0, where an is not equal to 0 with rational coefficients for all n. And a real number which is not algebraic is called a transcendental number. Now, every rational number is algebraic and every transcendental number is irrational. Students, make sure the vice versa is not true. In essence, every irrational number is not a transcendental number, and not all algebraic numbers are rational. Set of all algebraic numbers is countable and set of all transcendental numbers is uncountable. Arbitrary collection of disjoint open intervals is countable. Any non-trivial interval AB is similar to R where A is not equal to B. R is the set of real numbers. The set R of all real numbers is uncountable. Now, let's see some questions. If you have answered all the questions, you have understood the topic. Happy learning!